Welcome to Lesson 3 of Section 6 of the BJCP Training Program from the Brewers Anonymous Homebrew Club. We're continuing our look at the brewing process, and we're now into the subcategory we're roughly calling the boiling steps. Again, this is comprised of several steps of the process. They are not all boiling, but is what happens as we get things to the boil itself, and then after the boil before we pitch the yeast and get into what we're calling the fermentation steps. So let's get on with the details here. And the first thing we are talking about is the boil itself. In the last session, we made our wort and we transferred it into the boil kettle, and we're ready to go through the boil steps of the brewing process, starting with boiling our wort. Boiling the wort does some pretty amazing things chemically to the wort. Possibly one of the most important things that it does in terms of getting the clean beer we want without any undesired off flavors or aromas from infection is that it sterilizes the wort before we pitch the yeast, and we get the start of a very healthy fermentation. In this whole process, one thing that we've done, we haven't really talked about the details and measurements, but we have produced more wort than the amount of beer we're trying to package in the end. For example, in a homebrew level, we might want a 5-gallon keg of beer, and we're starting off this particular part of the process with 6.5 gallons of wort. Now, why is that? Well, one big reason is that the boiling process involves evaporation, and that reduces the volume. Nearly every time, if not every time, a recipe is written, the boil time is included in the recipe formulation to adjust not only for the volume change, but also for the concentrations of sugars in that final volume. Now, what I mean by that is the water is going to evaporate and reduce its total amount of final volume as a liquid. However, the sugars that started in that more than we needed volume do not change. So now the concentration of sugars is higher. So real quick note on that to further explain without getting too deep into this, because it is in things that we're going to talk about later, and this is not a how to brew course, but just to give you an idea of why that's important, we want a specific amount, a concentration of sugars in our final volume that we're adding the yeast to. If we started off with that number that we were aiming for before we started boiling, we'd have entirely too many sugars. It may even be too many for the yeast to consume, and we might have what it's called an under-attenuated beer and come out very sweet. So it's a balancing act between getting that final number with taking into account how much water we're going to lose. It sounds probably a little more difficult than it really is. It's an easy process to get your head around once you do it. But I just kind of want to explain why that's important, because it may sound like on the surface that more sugars is better because it leads to more alcohol. Not necessarily the case, depending on what your final outcome is for or at least your intentions for the beer. So, okay, went on a little more on that than I wanted to, so let's get back to this because it also does some other things as well. It also gets a brewer to their target color and flavor profile. Now, in this idea, I'm talking specifically about the malt flavor profile because we're going to get some other flavors out of our hops and yeast, but we haven't gotten to that point yet. But we can help dial in what we want from the malt profile, not only by specifically picking the malts that we're using in our grist and then in our boil, but how long and how intense we're going to boil, promoting some Maillard reactions and caramelizations during that boil. But like I said, that's just a piece of the puzzle in the overall flavor picture. Namely, we're also going to put in the addition of hops. There are several times that we can add hops into the boil. When the hops are added early in the boil and remain in the boil, the alpha acids from those hops begin to isomerize. And in that process, that distinct bitter character found in many beers develops and adds to that overall flavor. The later additions of hops to the boil, specifically closer to the last third of the end of the boil time, the flavor and aroma components start to come out. Again, recipe design comes into play a lot at this stage. Specific hop combinations added at strategic times are planned to get specific characteristics in the final beer. Now, while hops is the most common thing you add into the boil at this part of the brewing process, it's not the only thing. You can also add additional further ingredients late in the boil. And just very few examples of that are you could add lactose sugar. This is common in sweet stouts. It adds some unfermentable sugars and adds to the body and the sweetness of the beer. You can add dextrose, which is almost the complete opposite. It's a very fermentable sugar. You put in late in the boil, get it incorporated into the wort. The yeast can eat this very easily. It can raise your ABV. It can give you a drier, crisper fermentation character. You can add any kind of spices, that almost anything imaginable can be added at this point. And one thing that is important, but not necessarily a flavor component, it's more a visual component. You can add Whirlpool or Irish moss. These are additives that you put in towards the end of the bottle, and they help to coagulate the proteins and help them drop to the bottom of your fermenter come fermentation time and help clear out your beer. If you're really looking for a clear beer, this is called a hot side finding that you can add Whirlpool or Irish moss. There's other ones that can be done just at fermentation. I think technically during fermentation, and there's a lot more you can do post fermentation. This is the hot side one that is commonly used both in pro brewing and home brewing. As far as the boil time itself goes, this will vary greatly in modern brewing. But having said that, we're more concerned about what the BJCP exam is going to base their questions on. And we know that they still abide by the traditional 60 minutes for a boil that's using a pale malt base and a 90-minute boil for a Pilsner-based recipe. So for exam purposes, keep those times in the back of your mind in terms of the exam. Now, this entire process is done in what you've probably already guessed is a boil kettle, and this is in both commercial brewing and home brewing. On commercial boil kettles, they're typically heated by electric, direct fire, or steam. On the home brew side, the boil kettles are typically electric or direct fire. Again, everything in this section is said with an asterisk saying that there's an exception to every rule. So a quick look here. This is what one of several boil kettles can look like. I think I'll say they're typically this shape. They may have a copper top. They may be far larger, but they're typically cylindrical with some kind of top with access to add those late boil additions. On the home level, I wasn't even going to begin to start getting all the different boil kettles that are out there. There are so many. And if you even use an all-in-one system, you're basically having a transformer of a boil kettle. It all starts with a boil kettle, and you just kind of take away from it till you get to your boil kettle. But I don't think it's that difficult to wrap your head around that you needed 100 examples. So now we've added our hops to the wort during the boil. That comes with a lot of vegetal matter. And there's other heavy, near solid matter floating around that we don't want in our final beer. So there's a step we're going to do before we fully cool the wort and transfer it to the fermenter, and that's called the whirlpool. The whirlpool, in terms of a commercial process here, as we're using in our example, is the transfer of the boiled wort to a wider, shorter vessel through a side inlet that creates a whirlpool inside that vessel. And here's a graphic cutaway of a whirlpool vessel to show the direction of the wort as it's added. As the wort is being added, this whirlpooling action continues, and once it is fully transferred, it'll probably continue for a few minutes after that as well. Once that action is done, the wort's going to sit for about 15 minutes or whatever that brewer's process is, and this will let all of the matter, the heavier matter that's in that wort, collect to the center and fall to the bottom of that vessel. After that, the wort is transferred out another sidewall port to minimize the transferring of these solids into the fermenter. This is also the point where whirlpool hops can be added. Hops are added for a minimal but a rather turbulent contact time, extracting the fresh aromas before they can isomerize and leave the vegetal matter behind in that whirlpooling process. Now here's a picture of a commercial whirlpool, which is basically the picture we've been looking at, but now completely filled in. And here are several options for whirlpooling on the home brew side. You could have a port in your kettle that you can run or attach a pump to and run the wort through. You can have a device that hangs within the kettle, again, using the pump, or you can just use some old-fashioned elbow grease. Get a long enough spoon so that your hand's not in contact with what starts off as boiling hot wort, and just turn that thing for as long as your shoulder, elbow, and wrist will let you. Then yank the spoon out and let it sit for 15 minutes. I'll tell you, that is my process. Again, the less things I have to clean, the less things I have to unpack, the more I'm for, and I use a big spoon, and it works wonderfully. All right, now at this point, we really want to start talking about getting this fermentation started. So we're going to go on to the wort chilling part of this process. So we've boiled our wort for an hour, maybe more. We've done the whirlpool step, and even with that, we still have some very hot liquid, and it's not something that the yeast are going to live through. So we need to get to this chilling step of the brewing process. And that's exactly as it sounds. The wort is chilled to a pitching temperature before it's transferred into the fermentation tank. Not only does it keep our yeast alive, but it also gives the yeast the proper environment to thrive and not stress, which creates a lot of off flavors and aromas in and of itself. This is done in most cases with a plate-based heat exchanger on the commercial side of brewing. We're looking at just one of the models of a chiller you might see in a brew house. There are some styles that are done in other types of specialized cooling vessels. You may see the term coolship come out as you're studying brewing. These are open-top, flattened, shallow tanks that spread the wort out and lets the air cool it. For home brewing volumes, there's more options. There's an immersion chiller that chills the entire wort volume at once. There's a counterflow chiller where the wort flows one direction and cold water the opposite direction and works as a heat exchange. And there's even homebrew volume sizes of these plate-based heat exchangers. And there's also they don't do anything. It's called the no-chill method. This is where you put the wort into an airtight container and let the temperature gradually fall naturally before pitching the yeast. And pitching the yeast is what we're going to go on to next. We're going to talk about the fermentation process and steps that are involved post that as well before we get to packaging. So that all takes place in the next lesson, and I will see you there.